Okay, so I figured that I would show you how to do some physics problems so that you understand how physics calculation works in general, and you can sort of navigate your way around all the weird symbols and shapes. This is my first example. I only have 3. Now the force an object experiences when it gets hit, that's equal to the mass of the object multiplied by the acceleration it feels, or force equals mass times acceleration. This is a physical relationship that we can calculate. So if you had a bowling ball with a mass of 5 kilograms and you wanted to accelerate it by 20 meters per second squared, how much force should you use? Some of this is not very important. It's not important that this is a bowling ball. That doesn't really matter. The important things for the purposes of this calculation are everything that can go in this equation. So we need an F, an M, and an A. Now I have an A, it was 20 meters per second. I have an M, it was 5 kilograms. But I don't have a force, and that's actually okay because this problem wants me to figure it out. What is the force? So I need to solve for it. It is my variable. So I have an equation with one variable, and I can deal with that. So let's just plug that in there, and then figure this out. The force is going to be equal to the mass, which is 5 kilograms. And that 5 kilograms is going to be multiplied by the acceleration, which was 20 meters per second squared. And that seems weird that you have meters divided by seconds squared, but it's just a unit, don't worry about it. So what you do is you're going to take all the numbers, that's the 5 and the 20, and you're just going to multiply them together, because that's what's supposed to happen. So you do 5 times 20, and that just gives you the answer. So 5 times 20 is 100. So you get that the force is equal to 100. It's 100 somethings. So you can either memorize the unit, which is okay. The unit for force you can memorize as being a Newton, or you can figure it out from the problem. This is more complicated, but basically you're taking a kilograms number and you're multiplying it by a meters per second squared number. So your unit is actually kilogram times meters per second squared. Those are both fine. So you can memorize that the unit is N for newtons, or you can figure out that it's kilograms times meters divided by seconds squared. Those are both valid units for this problem. But the actual calculation, what you do is you just multiply the numbers. Just do the things with the numbers. The units all come in later. They don't affect it. Here's another example. Velocity is equal to the change in position divided by the change in time. That's a physical relationship expressed by this physics formula. Remember, the triangle is a delta, and it just stands for the change. So if you were running with a velocity of 5.7 meters per second, and you ran 100 meters, how much time would it take? Let's just isolate the important parts. That's my velocity. That's how far I go. So that's my delta x. That's how much my position changes. And I want to know how much time it would take. So I take the important parts and I just plug them in. The velocity is 5.7 meters per second. That goes here. The distance that I move is 100, sorry, that should say meters. So 100 meters. And then I want to find my change in time as a variable. So let me plug in these numbers. I have 5.7 meters per second. That's equal to 100 meters divided by delta t. And I might actually put that in a different color so it's very clear that that's my variable, and that's just one variable divided by delta t. So how do you solve this? The answer is not actually that you multiply by 100. That's not what you do. If you have a variable on the bottom of a fraction, what you're going to end up doing is taking everything on this side of the equation and just switching their places, swapping them. It's like they teleport and they change positions. So the delta t is going to end up over here, and the 5.7 is going to end up over here. And so what happens is that you get that delta t. Even though there's two symbols, the triangle t is just one thing. It's the change in time, the amount of time it takes. That's going to be equal to 100 meters divided by 5.7 meters per second. And 100 divided by 5.7 is some weird number. You probably have to use a calculator. It's 100 divided by 5.7. And I got 17.5. 100 divided by 5.7. Yeah, 17.5. So, based on my calculations, the amount of time that it would take is 17.5 17.5. And the units for time, we're always going to measure it in seconds. So 17.5 seconds. That's the answer. Finally, this is a more complicated one, a little bit, about kinetic energy. It says the kinetic energy, so this is just one thing, the kinetic energy. It's not K times E. It's equal to 1/2 times its mass times its velocity squared. So this is how you calculate the kinetic energy of an object. So if an object has 50 joules of kinetic energy, I don't know what a joule is, but it's okay because it's just a unit. So 50 joules, that's the important thing. And it has a mass of 25 kilograms. What's its velocity? Let's strip all the unimportant stuff out. The kinetic energy was 50 joules. So where it says KE, I'm going to put in 50 joules. And the mass is 25 kilograms. So I'm going to put in 25 kilograms right there. And the V is going to be a variable. So let me write that out. I have 50 joules is equal to 1/2, just the number, times the mass, which was 25 kilograms. So 25 kilograms. And I'm putting that in parentheses so that you know that that's separate. And then that's times the velocity. So let me put times V squared. How do you solve this? Well, this is just normal PEMDAS stuff, right? So you do PEMDAS. Except when you're doing algebra, actually, you start with this stuff and you go backwards. So I don't see any addition or subtraction. There's none of that there. There is some multiplication and division, actually. What I'm getting right here is 1/2 times 25. Told you that. 1/2 times 25 kilograms. That's going to be, let's see, half of 25. I should be able to do this. 0.5 times 25. 12.5, okay. So that's 12.5 kilograms. And that's times V squared. So, I have that V squared, so I can do a square root, but you got to be careful because algebra is actually PEMDAS backwards. That's how you do the order. Arithmetic is PEMDAS forward when there's no variables, but when there's variables, you do it backwards. So I still actually have a multiplication going on right here. I have 12.5 times V squared, because this is V squared. It's one block. So basically, I need to get rid of that 12.5 before I can do the square root. And I'm going to do that by dividing both sides by 12.5 kilograms. 12.5 kilograms, there we go. And that's going to cancel with that. And so what I'm going to get is that V squared is equal to 50 divided by 12.5, which is 4. Should have known that. So that means that V squared is going to be equal to 4. And then the units that I had were joules divided by kilogram. Finally, what I need to do is I need to get rid of this squared because it's V squared equals that number. So I'll take the square root of both sides. And so the square root cancels the square. And I get the square root of 4. So I end up with velocity is equal to 4. Now the unit is a little bit weird for this one too. You could memorize the unit for velocity if you wanted, in which case you would write down meters per second. Or you could figure it out from this equation. And one totally good unit is the square root of joules over kilograms. The second one is weird, so I wouldn't use that. I would just use meters per second. But you can figure out the unit, or you can just memorize it. The important part for this is that the answer is 4 whatevers, 4 of the units. Yep, that was it. Hope that was helpful. Don't worry too much if you didn't understand how I got the units. That's not the focus of this. The idea is just that when you're doing the numbers, you pretend like the units don't exist. They're sort of like stapled onto the end.